3.17. I made a mistake. This is a problem that we already did, so this is the same as, what problem was it? This was the same as 3.15, and so we saw there the denominator, the degree of 3 is bigger than the degree of 2, so the numerator wins the battle, and our answer is infinity. We saw this already. Sorry for giving you the same problem twice. Okay. Let's move on to 3.18. And 3.18 is interesting because it throws a little bit of a twist at us. And it might be tempting to say that the degree of the numerator is 2 and the degree of the denominator is 1, but that's actually not true because this is a 2, but it's inside of a square root. So this degree here is equal to 1. But what about the degree here? Well, it turns out the degree here is also 1. Or at least we should think of this as having a degree of 1 because it's a squared, but it's a square inside of a square root. So imagine these smaller terms weren't there. Your answer would be 3x. So this numerator is behaving like a degree 1 function. So that means we have to come out with an answer. Take that thought I did just a second ago, and it will solve the problem the old way, and then we'll come back and see how we could have just thought about it and just seen the answer by looking at it. Okay, so the old way would be to divide by the highest power, which would be divided by x in both of these. And that would mean that we would get the limit as x goes to infinity. Well, let's see, the denominator is easy. 2x over x minus 3 over x. The numerator is complicated because what we really have is we have something like this. 9x squared plus 6x plus 1, but that is all divided by x. Well, suppose I wanted to have this x, instead of being outside the square root, I wanted it to be the inside the square root. Because remember, what we're really doing is it's really like we're multiplying this by 1 over x, and we're multiplying this by 1 over x. So what if I wanted that x inside the square root? Well, outside the square root, it's an x. Inside of the square root, it's an x squared. Maybe that makes sense, right? An x squared inside is an x outside. So now what I really have done is I've really taken my 9x squared and divided it by an x squared, and my 6x and divided it by an x squared, and my 1 and divided it by an x squared. I hope that makes a little bit of sense because if I multiply by 1 over x, that means everything inside the square root is actually divided by an x squared and not a regular x. Okay, so with that being done, we're now ready to finish the problem out because this becomes the limit as x approaches infinity of the square root of, notice this becomes 9 plus 6 divided by x plus 1 over x squared. And then the denominator is 2 minus 3 over x. And so we can use our exact same thinking we've had all along. This becomes a 0, this becomes a 0, and this becomes a 0. And so our answer becomes the square root of 9 divided by 2, or 3 over 2. Now, again, I said we can actually think about this just by looking at the original problem. So let's do just that. So if we look at the original problem, could we have just seen the answer by looking at it? And I think the answer is true. I think the answer is yes. But we'd have to be a little bit careful for the way we look at it. So this degree, I look at the highest power. The highest power here is 9x squared, but the highest power on the front is like the square root of 9x squared. So really, the highest power on the numerator is a 3x. And then the highest power on the denominator is a 2x. And so now we can see that the degree of the top, the degree of the numerator, and the degree of the denominator are actually equal to each other. And this one has a coefficient of 3, and this one has a coefficient of 2, because this coefficient was actually 9, but it's the square root of 9, and so that coefficient is actually 3 instead of 2. And so now we could divide them out, and we could see that our answer is 3 over 2. So once you get good at thinking about square roots, you can kind of jump right into this answer. Okay, let's jump to 3.19 and 3.20, and I'm going to do these kind of quickly because these aren't the central ideas for this semester, and because we're kind of doing a shortened version of the semester, this is one of those things we won't focus on for too long. But there's a really nice result here, and that is that we're thinking of the limit as x goes to infinity of the square root of x squared plus 1 minus 2x. Okay, well this is a little bit hard to deal with because notice I might say this is a degree 1 and this is a degree 1, and do they cancel? What happens? This is hard for me to make sense of. So what am I going to do? Well, the trick, as always, we have a square root. So what should we try? We should always try to come up with a conjugate. So every time you see a square root, you try to make a conjugate. In general, when we have subtraction is hard to do with limits, so we convert it to either multiplication or division. You can convert it to multiplication by factoring, convert it to division by multiplying by a conjugate. So these are the general things that we try. In this case, we're going to multiply by the conjugate. And so I'll have the limit as x goes to infinity of the square root of x squared plus 1 minus 2x over 1 times the square root of x squared plus 1 plus 2x divided by the square root of x squared plus 1 minus 2x. Now let's simplify all of that out, and I'm going to go kind of quick here. Again, this is not the focus of what we're doing right now, but I want you to see these to know that these problems exist and that you're capable of solving them. So this one becomes the limit as x goes to infinity. If you look at the top, it looks like we've got an x squared plus 1 minus, and then we got x squared plus 1 minus 4x squared. And then on the bottom, right, so we get these two multiplied, gives me x squared plus 1. This and this cancel, and then the minus 4x squared is the other term. And so this gives me divided by the square root of x squared plus 1 minus 2x. Let's write this out one more time. The limit as x approaches infinity, we end up with negative 3x squared plus 1 over the square root of x squared plus 1 minus 2x. And now I can just look at this problem and realize, oh, this is now looks like not too bad of a one because this degree is equal to 2. But what about the degree of the bottom? It is equal to 1. So what does that mean for my answer? That means my answer must be either infinity or negative infinity because the top is going to win. So this is the winner. So since this has a squared and this one still just has a plain x on it, the top is the winner. And now I just have to ask, is it plus or minus infinity? And this minus 3 tells us the answer is negative infinity for our result. Okay, I hope that made a little bit of sense. If it was a little confusing, no big deal. But just, kind of, hopefully this makes a little bit of sense. As you move to Calc 2, you'll be using tricks like this more often in a couple of the sections. Okay, so now we have the limit as x goes to infinity of sine x. This looks really intimidating, but what does sine of x look like as a graph? Sine of x looks like this. And how long does it do that? It does that forever. And so does sine of x ever approach a point? Does it have any asymptote? Does it ever reach a single value? The answer is no, so this limit does not exist. So sine and other things that kind of continue oscillating over and over again do not exist. Okay, as we go, so as we go through this exercise 3.19 and 3.20, I don't want to focus on those, so I'm going to make a few modifications to the homework. We're still going to have some other problems, and we're going to have one more video for you to watch. But before we do that, let me just tell you what the homework is. So we're going to skip these problems because they're kind of close to things like 0.19 or 0.20. So our new homework, just do 1 to 19 odd. There'll be some of those that are just regular fractions that we take limits of, and some that have square roots in them. Do number 25. 25 is going to be a really good one for you to think about things. And 45, I put a star here. Reason is 45 really falls into what we might call a creativity problem. I think it's really interesting, and I would love for you to do it. I don't want to make it normal homework, so what I think I'll do is I think I'll make number 45 bonus. And what I would like you to do to do the problem number 45 bonus, this is what it takes. So problem 45 bonus. Problem 45 bonus. Here's what I'm going to ask you to do. I'm going to ask you to solve it, and you can work in groups if you want. So you pair up or do it individually if you need to. But so number one, solve the problem, and then you have to explain your solution. Explain your solution, and how do you explain it? You can explain it in 2 different ways. You can either write an explanation, or you can video an explanation. So I actually kind of prefer the video explanation idea. So if you have a really nice solution, you can write it down, and then you could make a quick little video. Hopefully it's not really long, and you can send that to me, or you could drop it in the Moodle. If you do the bonus problem, make sure to tell me, because you know I don't always look really closely at the complete incomplete problems, and then you know I don't always look really close at the complete incomplete problem. So make sure you let me know, hey, I did the bonus, I have the video, so look at it and see how it went. So hopefully that goes really well. I do want you to try exercise 3.21. So 3.21 is a really good problem. It's getting at the question of how do these affect the shape of our graphs. So try 3.21, and we're going to look at it and 3.22 together in just a minute in the next video. And it'll kind of round out a lot of these ideas of how does calculus help us understand what graphs look like.